We'll be starting in 2 minutes, guys.
Am I audible? Am I clear enough?
Yeah, Shreya. You're audible and you're clear enough. Yes.
Okay. Declare A as 3. So I check if A modulo 2 is equal 0. So I'll check that if this condition is true or not, then only. So if I have A equal 3, so this is not true. So this won't be evaluated. Now we have else statement. Else and if else go in pairs. So I'll be complementing if using else statement. So it is only evaluated if the condition fails. So how do you see it from a flow diagram? I have a condition here in if, and if that particular condition is true, I'll do something. And if that particular condition is false, I'll go to the else statement, and whatever is there in else, whatever we are doing in else, that will be evaluated. So for example, see this similar case, I have declared A as 3. So A modulo 2 equal 0, which is a false statement because 3 modulo 2 is not equal 0, it's 1. So this won't be evaluated, and it will directly go to else, and we'll evaluate this whatever is there in else, and we'll get the integer is odd. So I have three questions from whatever I taught just now. And you need to answer the output of all these one by one. So clearly see how is it, and my fellow coordinators will be checking if your answer is correct or not for all the three programs. So I'll give you 5 minutes to think about them and write the answers. So maybe due to some technical issue on YouTube, it's not being streamed perfectly. So I'll just restart one. Till that time, you can screenshot this and just start solving it. So I'll start from the beginning. We have if statement, and in if a particular condition that is given, if it is true, it will be evaluated, and if it's not true, nothing will be done since there is no else statement over here. Then we have else statement where we complement if using else. So for if the condition is not true, we use else statement. If the condition is true, whatever is there in if, that will be evaluated. And if that condition is false, whatever is there in else will be evaluated. So for a case in this example, I had a equal to 3. I declared a as 3. So 3 modulo 2 is not equal to 0. So this particular condition is false. So this won't be evaluated. And then we'll go to the else part and we'll print that the integer is odd, meaning else part will be evaluated. So yeah, these were the 3 questions you are meant to solve. I'll wait for 2 more minutes for you because it's a bit confusing at first. I think you guys would have thought what will be done in these. So I'll start by the first one. In this, I've declared A as 4. So the first condition, 4 modulo 2 equal 0 is correct. And this will be evaluated. So we'll see out even. And now I have changed A to A plus 1. So now A becomes 5. This else won't be evaluated because this if was already true. And now I'm printing the value of A. So A's value has changed from 4 to 5. So I'll print 5. So I'll have even and 5 printed. Even and 5 will be printed. So yeah, you can see even and 5. In the second one, I have again declared A as 4. So 4 modulo 2 equal 0. So this is true and I'll have even printed. And now I have changed A to 5 again. Now, again, one more if statement is there. So 5 modulo 2, now A's value is 5. So 5 modulo 2 equal 1 is also true. So this will also be evaluated and have odd. And again, A's value will change from A to A plus 2. So 5 becomes 7. So I'll have even, odd, and then A is again printed. So I'll have 7 as well. So this will be the output, even, odd, 7. And in the third case, I have again A is declared as 4. A modulo, this is true. So this will be evaluated and then A becomes 6 now. Now again one more statement is there. If now this isn't true because 6 modulo 2 is 0. So this won't be evaluated and the value of A remains 6. So even and 6 will be printed. So I'll have even 6. Now we'll have dangling else statement. So like we need to know which else refers to what if. So else is followed by a previous if and it implements from the previous if only. So for example, if I have this if where a equals 4 in this particular example, so the state condition in this is true. So I'll print even and the value of a will change to 5 now. Now I'll check for this. Again, this is true. Okay, so 5 modulo 2 equal 1. So this will be evaluated and the value of A will now change to 5 plus 2, 7. But now since this if is already evaluated and the else which is followed by this particular if will not be evaluated because I already checked on this if. So that is why we refer to dangling else statement. And this particular else belongs to the if which is just before it. So I'll have even printed, odd printed, and then 7 value printed. Nested if else. So nested if else is like we have one if else within the other if else. So like for example we can have it. Okay, so if I declare a as 4 and I'm asking that if a equal to, so this is not true, so we'll not evaluate this and we'll go to the else. Now in else I have another if statement, so there's what we can nest it. I can add an additional if inside the else itself, and I'll say okay, if a equal 3, then I need to see out 3. So yeah, this is also not true, so I'll go to the other else which is just followed by this particular if. I'll go to this else, and now again one more if statement is there, and I have a equal 4 which will give 4 because this statement is true. I declared previously a as 4 and I have not changed its value anywhere. So yeah, so a equal 4, it's true, and I'll have 4 printed. One more method to do this similar set of thing, we can use else if. What happens in else if is I can have one condition. If this condition is not true, then what? If this condition is not true, then what? So for that, I use else if statement. Else if a equal to, then what? If this is not true, which in this case is not true, so I'll use else if. If this is not true, then what? Else if this is true, or what? Okay, so I have a equal 4, so this is true, so I'll evaluate this. So we need to know the flow in which we are writing if else. It's very important in which the order should be correct. So that's why we have a flow diagram for writing condition in else if. So I'll first start with the if statement, and I'll have a particular condition. If that condition is true, whatever is there in that if loop, we'll execute that. If that particular condition is false, I can use else if condition. If I'll do something over there, if the condition is true, again, if that condition is false, I can use the else statement and I can do whatever I want to do if this condition in else if is also false. And then I can have the rest of the code. Is there any issue with my screen or something? Okay. Okay, I'll slow down a bit. It's going too fast. Okay, so yeah, I think this was fine enough. What we wanted to know in if else. Now we'll have logical operators. I think this was discussed by Sean as well, but I'll still be covering because it's a very important aspect in if else statements as well. So we represent and by and then or by two slantings. So what I have is a modulo 3. So for and is only evaluated when both the statements are true. So both the conditions that we are having in if, we can have two conditions, and then we want that both the conditions should be true. So we introduce and in the other case, if we want that either of the conditions can be true, so we introduce or statement. It is very useful while write these logical operators while we use if else. So for example, if I have a equal 4, so I have two conditions. If a modulo 3 equal 1, which is true, 4 modulo 3 is 1, and then a modulo 4 equal 0, which is again true. So this if completely if condition is true, so we'll evaluate this part. And again, if I have a equal 4, so a modulo 3 is true. I don't need to check because either of the statement is true, I'll implement. This condition becomes true and I'll evaluate it. But for example, if in this case, instead of 0 over here, I might have 1. So If I have 1 instead of 0 in the second condition, so this condition becomes false. So in this case, it won't be evaluated. But in this case, if even if I have instead of 0, 1 over here, it will be evaluated because one of the statement is true. Short circuiting is nothing but the thing this in the case of and if the first condition is false, then the second condition won't be evaluated. And in or, if the first condition is true, then the second condition won't be evaluated because we know ultimately if the first is false, the entire condition will be false. And in or, if the first condition is true, the entire condition will be eventually true. Now we'll go to loops. We'll start off with while loop. While loop is important. While loop, we how do we state while loop is we run the loop till we write a particular condition in brackets, and whatever we write here, and we run it till that particular condition that we are writing is met. So, for example, I have here a equals 0, sum equals 4. I write a particular condition that a is less than 4, and I write that sum equals sum plus a, means I am incrementing sum by a, and I'm incrementing a again by 1. So I every time I iterate through the loop, I am incrementing a by 1. So I increment a by 1 until the time a is equal to 3, the loop terminates. The loop is over, and the final value of sum is whatever we get by incrementing by a. So, the most important applications we use is to calculate the number of digits in a number. So, what we do is we use a while loop. We state the condition that till the time a is greater than 0, a is not equal to 0, basically. We continue this loop. We have a variable, a is a loop variable, and we have another variable which we are counting the number of digits upon. We'll initiate it as 0, and then after dividing the particular number by 10, we'll increment the digits by 1. And we keep on incrementing till the time a becomes 0. This is the technique we use to calculate the number of digits. And finally, when only a unit digit is left, and when you divide that particular unit digit by 10, a will eventually become 0, and it won't be implemented further, and the loop will terminate. So till unit digit we need to count. So that principle we use while counting the number of digits. For loop. For loop is very similar to while loop. In this, just the declaration is a bit different. We have a variable definition, we have a condition, and then we are incrementing or decrementing the variable or something in that particular loop. So we define a variable, we have a condition till the time this condition is met, this loop will keep on running, and we do some stuff over here. We can use that particular variable to increment whatever we want to. So for example, in the similar case as while loop, what we do is we declare a loop variable I. I initiate it as 0. I give a condition that till the time I is less than 20, meaning I is equal to 20, I is equal to 19, sorry. And I increment I by 1, I equal I plus 1. And then I increment sum by I as well. So I'll increment sum equals sum plus I, means I'll be incrementing sum by I. I'll I'll I have I equal to 0, 1, 2, 3 till the time it becomes 19. This loop will keep on running. Okay. So I think I have a question over here. This is a very simple for loop question, but you need to think about it and answer. I think you can you can scan this QR code and you will be able to answer this question. You'll have options over there. My fellow coordinators will share the link of this as well. I'll wait for 5 minutes for you to think about an answer. Think I'll be able to see the results as well. Okay. Yeah. Okay, so a lot of people have answered now. Mm, I'll wait for 2 more minutes so that you are able to think. Okay. Majority of the people are voting 5. Let's see the correct answer. Think about and then answer. Okay, after 300 people, I'll probably show the correct answer. Okay, so I'll be summarizing things in a while. Till the time people vote. I'll We started with if statement. If the condition is true, it is evaluated. Then else, which is followed by if. Then we had an example to understand the sequence. And then we had dangling else statement, in which we learned a very important point that a particular else is followed by if it is only evaluated the if that is before it is not evaluated. And then we have if else statements. And then we had a flow diagram, which is very important if you want to understand how if else works. And then logical operators, and or operator. If both conditions true, then only and is evaluated. Either of the conditions true or is evaluated. Then loops, we had while loop, which syntax is very basic. You just have a condition and you do some operation till the condition is met. The loop keeps on running. And then we have for loop, whose we declare a variable, we declare a condition, and then we want to increment whatever we want to increment or decrement, we declare here, and we do some stuff with the variable that we declare. And then, yeah, this question. Okay, so I think I'll present the answer to this question since 300 people have already voted. So, yeah, the correct answer was 5, and the majority was correct. So, as you can see, one like in 5 iterations, the condition of sum is met, and in 9 iteration, the condition with I is met. So, when in 5 iteration, both these conditions are satisfied, so we'll take the answer 5. It was pretty easy if you had think how many iterations will this loop will go for. Okay. So we can convert a while loop into a for loop, which is very easy because both of these are very similar. Whichever condition we are writing here, we can directly write it over here in for loop condition in between. And then we can, whichever variable we are declaring inside, we can declare it in the statement itself. And then we can increment or decrement inside the whichever whatever we are incrementing and decrementing inside the while loop, we can increment and decrement in the for statement itself. It's both are mostly the same. Okay, so we'll move on to arrays. So arrays, what exactly are arrays? So arrays is a particular data structure in which we store a particular type of data in contiguous memory location so that it's easily accessible. So we have array, if we have declared an array and I want to access a particular element, so I can directly access it by just stating the index number. Indexing in array starts from 0. You'll learn more about it in vectors as well. So indexing starts from 0 till n minus 1. So how do we initialize an array? So we specify firstly the data type, whatever data type, it is a float, int, a character data type, whatever data type, we specify the data type first. And then we write the size of the array in the square brackets after specifying the variable name. So I specify 50 and 9, whatever I specify. And then whatever I have already specified, I can store at max the n elements that I have specified. So in mark array, I can specify only 50 elements. In age array, I can specify only n elements. In symbol, I can have only 9 elements. Okay, so array is a simple example. If you want to learn, I declare a particular array named ARR, which has maximum 10 elements. I declare the first element, which is index 0 as 1, then second 2, 3, and 4. I declare the first 4 elements of the array, and then I want that these 4 elements should be printed. So I use a for loop. for loop for printing the elements of the array. How do I do that? I I need to change the index every time I am printing. So I declare it as the loop variable now I need to print it till the value of I is 3. So I specify the condition that I needs to be 4, and I need all the consecutive indexes. So I'll do I plus plus. And now if I want continuously all the elements, then I'll remove the end L. If I want that elements should be printed in 1 to next line, I'll have 1, 2, 3, 4, and you can introduce end L. One of the most important application of using array would be to identify a set of element using loops. So for example, I need to specify in a particular data type what is the maximum. So if I have a set of marks of around 50 students, I need to specify which is the maximum marks in that particular data set. So what I do is I use a very simple logic that I initialize the maximum marks as 0, any initial value you can give. And then what I do is I'll iterate through all the elements of the array of marks. I'll start from index 0 till I equal to 49, and I'll keep on incrementing I. What I do is, if that particular mark I is greater than maximum marks, the maximum marks will take the value of mark I. So what happens is, whenever that maximum marks is reached in that particular data type, the value of maximum marks remains constant, because this condition will never be true after that. When I reach the maximum marks, this condition would be true. So that logic I use, and I get the maximum marks by using this particular if condition. So yeah, I think this was mostly what is required in array. Now, I think Riddhi, because vectors is a better data structure than array, so it's more dynamic. So my fellow coordinator Riddhi will be taking over, and she'll be taking you through vector and strings. Yeah.
Hello, am I audible? Vectors are used to between a vector and during the execution of the program. So a vector is dynamic. We write the term vector, integer in this case, and then we specify the way. There are very first method, it's vector int vn. So what this does is this makes a vector v of size n. And it's similar to how you declare int arrn. So this statement makes a vector of size n. Now, if we look at the second statement, in the second statement, we write vector int v size comma value. So for instance, if I declare vector int v 2 comma 2, what it will do is 2 will be the size of the vector, which means 2 will be the number of elements in the vector, and each of these elements will have value 2. So after writing that statement, we'll have a vector v, which is 2 comma 2. This exact same statement can be executed in 2 steps as well. So in the first step, we'll just be declaring the vector. And in the second step, we'll be assigning the values to the vectors. And this is the third type of declaration, where we basically specify the values of the vectors in balanced braces. Now note, just like an array, a vector can be of any data type. In the above examples, I have used the integer data type. However, we can use float, char, boolean, or any other data type for vectors as well. Now the indexing and positioning in a vector is similar to that in an array. So like in an array, we index the values from 0. So the very first element has a index of 0. Similarly, we can, just a second guys, there's some technical issue with YouTube, so I'll be pausing for a while.
till the time, I think I'll see the chat if there is any doubt from the previous part. She has taught or I have taught.
Yes, if you have any doubt, you can ask us right now and you can put it up in the chat. Okay, so someone has asked, why do we need vectors? So as I mentioned, that the size of a vector can be changed during the execution of the program. So sometimes you'll find places where you do not know the size of the data type beforehand, and it can change during the execution. So that is when we need vectors, and also when we need to store a list of elements of the same data type.
I think someone has asked on the syntax, what does it mean? N mean in vector int v of n.
So over here, n means the size of the vector. So it's similar to when you create an array of n elements, you declare int, the name of the array, and in the square brackets, you write n. So in case of a vector, if you want to do the same thing, hi, so I'll be resuming the presentation. Yeah. So the indexing in a vector is exactly the same as in an array. It starts with index 0. Now we will be moving to common functions in a vector, which make it easy to use. So the first function is v.pushback a. What it does is it inserts an element a at the end of the vector v. For example, if you look at this example here, we have declared a vector v of integer data type. Now we have written v.pushback 1. So what this does is this will insert element 1 at the end of the vector v. So initially the vector v does not have any element. Now it will push the element 1 to the vector v. So now the vector v will look like this. Now when we do v.pushback 4, it will insert 4 at the end of the vector. So 4 will come after 1 and the vector will be 1 and 4. Similarly, v.pushback 8 will push 8 to the end of the vector and the vector will be 1, 4 and 8. The second function is the v.popback function. In the v.popback function, it removes the last element of the vector v. So when we do this, it removes the last element 8 and the vector now becomes 1, 4. So we can clearly see how the size of the vector is changing during the execution of the program, whereas in an array, this was not possible. Now the v.size function, it returns the number of elements in the vector v. So initially the number of elements in the vector v is 0. So the size of the vector is 0. In this step, the size of the vector is 1. Over here it's 2 and so on. V of I. So this notation is very similar to that in an array where we write the name of the array, square brackets and the index. So this returns the element at the ith index of vector v. So this is like very similar to the array part. Now we look at an example. In the example, we're first declaring the vector v. We're printing the initial size of the vector, which is 0 since there are no elements in the vector. So we can see that in the output, the initial size is 0. Similarly, now when we push back 3, the vector will have the element 3 in it. When we push back 4 to it, the vector will now have 3 and 4 in it. So the size of the vector after these two pushbacks will be 2 since it has 2 elements, and that will be printed on the screen. Now we're using this loop to print the elements of the vector v. The vector v has 3 and 4 in it, so this will get printed. Now we're using v.popback. So v.popback will remove the last element of vector v, which is 4. So after popback, the only element in v will be 3. So the size of the vector will be 1 and the elements of the vector v will be 3. Now we go on to the next function, v.clear. It basically erases the vector v. So after this function, the vector v has no elements in it. The next function is v.resize n and v.resize n, val. These functions will be better understood with the help of an example, which follows. So vector int v 1, 2, 3, 4, 5. This basically assigns or creates a vector having these 5 elements. Now when we write the function v.resize 4, it means that after this function is executed, the size of the vector v should be 4. The number of elements in the vector v should be 4. However, initially we have 5 elements in this vector, so it will automatically delete the last element. And after executing this line, when we print the vector v, it will be 1, 2, 3, 4. Now, when we write v.resize 6, it means that we want the final size of the vector to be 6. However, the vector has only 4 elements, so we will have to add 2 more elements. But we haven't specified which element to add. So by default, the compiler will add the default integer, which is 0. And after executing this line, when we print the vector v, the output comes out to be 1, 2, 3, 4 and 00. Similarly, now when we do v.resize 8, 9, we want the final size of the vector to be 8. However, the size right now is 6. So we need to add 2 more elements. And over here, we've mentioned 9. So instead of adding zeros to it, since we have mentioned a specific value, that specific value will be added to the vector. So the 6 elements will remain as it is. And for the other 2 elements, 9 will be added. Now we'll be moving on to a problem related to vectors. So the problem statement is, you are given a string. A string is basically an array of characters. So that is what you can refer to it as right now. Of length n, consisting only of the characters plus and minus. If the character is minus, you add 1 more minus to its right. And if it is plus, you add plus to the right as well as the left. You are asked to print the final reversed string. So before looking at the reversed part, let us look at the logic of the code. So for the logic of the code, let's go to the editor. I hope my screen is visible to everyone clearly. Can someone please answer?
Yeah, it's visible.
Yeah. So initially I'm accepting a character array as it was given in the question of size n. So I will be accepting the character array from the user. Now I need to modify the string and then I need to print the final string. So according to the question, let's say the initial string is this. So if the initial string is this, we know that for every minus in the string, we will be adding an extra minus to the right. So the extra minus and plus that I'm adding, I'll denote with M and P so as to not get confused. Now when we encounter a plus in the string, we will be adding another plus to the left as well as the right. For this minus, we'll be adding a minus to the right, and for this minus, I'll be adding a minus to the right. So we can clearly notice that if in the original string we had one minus, then in the new string we will replace it with two minus signs. And if in the original array we had one plus, in the new string we will be replacing it with three plus signs. So that is exactly the code I've written. Over here we'll be iterating through the elements of the array, which is the character array which has been inputted from the user. If the element is a plus, then in the vector we will be pushing three pluses because for every plus in the original string, we need three pluses in the new string. And else, which means that if the element of the array is a minus, then we will be pushing two minus signs into the vector. And finally, we will be printing the vector v. However, in the question they've mentioned that we need to reverse the vector v. So for reversing the vector v, we will be using a function reverse. When we use reverse v dot begin, v dot end, it reverses the vector, and then finally we can use a loop and print the vector. I hope this was clear to everyone. So this is the attendance link, which will be shared in the chat as well. So please don't forget to mark your attendance. I'll be on the slide for a minute or so. You can scan it and give the attendance. Also, please note everyone has to fill the Google form irrespective of whether you're attending from YouTube or Teams. Okay, so if you've marked your attendance, it's fine. Otherwise, my fellow coordinators will be sharing the link shortly. You can mark it then. Okay, so now we'll be starting with strings and ASCII. We are done with vectors. So the session contents include ASCII, strings, input methods, some string functions, and then we look at a problem. So what exactly is ASCII? ASCII stands for American Standard Code for Information Interchange. Each character has a unique ASCII value, which is used to store it in the memory. So what exactly happens is a character is basically anything on your keyboard can be considered as a character. Some examples include all the alphabets and all the digits from 0 to 9, the hash sign, the star sign, and so on. So every character has an integer value associated with it. Now, the integer value associated with a particular character is fixed. So, for instance, if you want to look at the integer value of A, then you can declare a character ch as capital A, and then you can write int x equals integer of the character. Now, when you output x, and if I run the code, then you'll see that the output is 65. So 65 is the integer value associated with the character A, capital A, and that is called as the ASCII value of a character. So this is a table where I have listed all the ASCII values of all the characters. And this is something which comes out to be very useful considering the next slide. So basically, in case you want to convert a character to its corresponding uppercase, one method to do so is you can write if condition. So if the character is small a, then you can convert it to capital A. Right, so one way to do that is if you have a lowercase a, then you can convert it to the corresponding uppercase by using an if condition. However, to do that, you will have to write at least 25 to 26 if-else statements, which is usually not feasible. So another thing is, since every character has an ASCII value associated with it, which is basically an integer, you can add and subtract characters. So if you look at this table, you will see that the ASCII value of capital A is 65 and the ASCII value of small a is 97. So the difference between the ASCII values of small a and capital A is 97 minus 65, which is 32. Now, if you look at the capital B, its ASCII value is 66 and the ASCII value of small b is 98. The difference between the ASCII values of small b and capital B is also 32. So we can make an observation that the difference between the ASCII values of the lowercase character and the corresponding uppercase character is a constant. This is something which we can utilize to convert a character to its corresponding uppercase or its lowercase. So if we look at the code here, over here I've declared a character ch as the lowercase a. Now if I want to convert this lowercase a to its corresponding uppercase a, I can write ch1 equals ch1 plus capital A minus small a. So ch1 is already small a, so we can clearly see that ch1 will be equal to capital A. Similarly, if I want to convert a character b to its uppercase, I can write char c equals b and c equals c plus capital B minus small b. However, we did notice that the difference between capital A and small a and the difference between capital B and small b is a constant. So over here, I can replace capital B minus small b with capital A minus small a. Hence, we can see that for any given character, if we want to convert it to its corresponding uppercase, we can simply add capital A minus small a. Likewise, if we want to convert any character to its corresponding lowercase, then we can simply add small a minus capital A to it, and it will get converted to the corresponding lowercase. Also, if we look at the numbers, then the ASCII value of 0 is 48. So the ASCII value of character 0 is 48. However, if I want to use the character 0 as an integer 0, then I need to subtract 48 from 0, or I need to subtract the character 0. Hence, to represent any digit, any character as its corresponding number, we should subtract 48 from it, or we can subtract 0 character from it, and then we can convert the character to its corresponding number. Now let's move on to strings. What exactly is strings? So a string is basically a collection of characters which are surrounded by double quotes. Now we had looked at character array in the previous slide. However, strings has certain benefits over a character array. So strings offer certain inbuilt functions which is useful. That is the reason strings was created, despite the fact that strings is similar to a character array. Now, if we look at the declaration and the initialization of a string, it is similar to the declaration and the initialization of any other variable. So for a variable, if you want to declare a variable, you write the data type of the variable and the name of the variable. For example, int a. Similarly, for strings, you write string s to declare the string. If you want to initialize the string, you need to make sure that whatever you're initializing is within double quotes. That is how a string is identified. So this is the declaration and the initialization part. Now for input, the input of a string is also very similar to that of any other variable. However, there is one small difference. So the thing is, whenever we use C in S, so now we're writing string S, C in S. Cin does not consider spaces. So if I write a string as this looks amazing, Cin will not consider spaces. So as soon as it encounters a space, here, it will stop considering it as an input. So now when I try to print the string S, this looks amazing will not get printed, only this will get printed. So whenever you use Cin, you need to ensure that the string you're taking will have only one word. If you want to have more than one word in a string, then you should use getLine CIN_str. This will ensure that all the spaces and everything comes in the string. Now let's look at some string functions. So the first string function is the length function. The length of a string is similar to the length of a vector. So length of a string is the number of characters in the string. Now, if I declare a string a as hide, it has 4 characters in it. So whenever I print a.length, it will output 4. Similarly, string b has 5 characters in it. So when I output b.size, it will print 5. Now, s.clear. S.clear basically clears the string. So it erases all the characters from the string. So if I have any string, all the characters of it will be erased. Now I have this question here. You guys can answer it on Slido. I'll go back to the question in case anyone wants to see it. I'll wait for another minute, after which we can discuss this. So most of you have voted 0. Let's see. Okay, so as I mentioned earlier, the clear functions clears the string. So string A initially has hide in it. However, when we write clear, it clears the string. So now the string has no characters in it. So the length of the string will be 0. So the correct answer was 0. Now let's move ahead. We have the append function. So s1.append s2 is the first variant. In s1.append s2, it appends all the characters of s2 at the end of s1. So if we look at this example here, we have string A as hide and string B as hello. So when I do a.append B, it will attach all the characters of the string B at the end of string A, and the resultant output will be hide and hello. Now s1.append s2, s2 index, s2 num. What it does is it will append these many number of characters of string s2 to the end of string s1. These many number of characters will be starting from this index. So if we look at this example here, we have b.append c, 1, 4. What happens here is it is supposed to append 4 characters of the string c to the end of string b. However, it cannot take any 4 characters. Those 4 characters will start from index 1. So H has index 0, E has index 1. Now we take 4 characters from here, ELIC, and we append it to the end of string B. So the output is hello and ELIC. This same function s1.append s2 can be performed using the plus operator. So the plus operator is used to concatenate 2 strings together. So if I write string A as hide and string B as helical, and if I declare a new string C as A plus B, then string C will automatically have hide first and helical later on, and it will be hide helical. Similarly, if I do A equals A plus B, the string A will get updated and the same thing will follow. The next function is the reverse function. Now, the reverse function is as simple as it looks. It basically just reverses the string. So if I have a string s as program, and if I write this statement reverse s.begin, s.end, it will simply reverse the string. So the output will be margorp. S.substr I, n. So this is basically the substring function. What it does is it takes part of a string of length n starting at the ith index. So the string s, if it's program, and if I have written s.substring 1, 3, what it will do is it will start from index 1 in s. So p is at the 0th index, r is at the first index. So from this first index, it will take 3 characters, so r, o, and g. So str will have r, o, and g, and when we print it, it will be reflected. Now there's another function called as the find function. In the find function, when we use s1.find s2, it will find the first instance of string s2 in string s1. So if we look at the example here, we have the string banana and we have string s2 as an. An comes twice in string s1. It occurs once over here and once over here. So when we use the s1.find function, it will find the first instance of string s2 in s1. So the first instance is over here, and in the first instance, the index of a is 1. So when I output s1.find s2, the output will be 1. s1.rfind s2. This function is used to find the last instance of string s2 in s1. So when I do s1.rfind s2, it won't find the first instance, it will find the last instance. So in the last instance, the index of a is 0, 1, 2, 3. It's 3, so the output will be 3. Similarly, if I try to do s1.find s3, now s3 is a string us. Clearly, s3 is not a substring of s1. So no occurrence of s3 will be found in s1. So the output will be a random big value, which will not correspond to any index. Now we go on to the comparison of two strings. So one might wonder, how exactly are you going to compare two strings? Like we can compare two integers. We can say that 6 is greater than 4. However, how can we say that one string is greater than the other string? So for this, we know that a string is a collection of characters. And for every character, we saw that it has an ASCII value associated with it. The ASCII value is basically an integer value. So over here, to compare two strings, we should compare the ASCII value of the character of the strings, which is what can be compared. So how exactly do you compare the ASCII value of the characters of the strings? This comparison is done lexicographically. Now, lexicographically means that we compare one element at a time from left to right. It compares the corresponding characters in both strings until it reaches the first character, which is different in the two strings. Now, when we look at an example, it will be clearer. So over here, we have a string S1 as apple and a string S2 as app store. So what it will do is, it will compare the first character of both strings. It will compare A with A. Since the first characters of both strings are same, it will move on to the next character. So now it will compare P with P. Since these characters are also the same, it will move on to the next character. Now it will compare P with P again. These two characters are also the same. So it will move ahead and compare S with L. Now, if we look at the ASCII values, we will see that the ASCII value of small s is greater than the ASCII value of small l. Thus, we can say that the string s2 is greater than the string s1. Similarly, if we look at it the other way, we find that the ASCII value of small l is less than the ASCII value of small s. So the string s1 will be less than the string s2. So over here, when I try to output S2 greater than S1, so S2 is indeed greater than S1. So the output will be true and hence it will print 1. Now, to compare if two strings are equal, it's clearly visible that those strings will be the same if all the corresponding characters are same. So over here, S1 equals S3. So when I'm trying to print S3 equals S1, the condition is evaluated to true and the output is 1. Similarly, now if we look at this example, S3 and S4, we're comparing the first character of both strings. A is equal to A. We move on. We're comparing small p and small p. They both have the same ASCII value. We move on. Now this p and this p also have the same ASCII value. However, we've reached the end of string S4 and there are no more elements left to compare. So in this case, what we will do is the string which has more number of characters. So S3 has more number of characters. So S3 will be greater than S4. So over here, when we print Cout S3 greater than S4, it evaluates to true and the output is 1. Now we'll be moving on to a problem. This is the QR code of the problem. This problem is there on Codeforces. So if someone wants, they can see the question from Codeforces, and I've also pasted a part of it on the screen. So the question is as follows. A string is called square if it is some string written twice in a row. For example, the strings AA, ABC, ABC, and all these are square strings. But the strings AAA, this and this are not square. For a given string S, we need to determine if it is square. So we can clearly see in this question that for a string to be square, it should be some string written twice in a row. So the length of this square string will be twice the length of the string it is made up of. So we can clearly see that the length of the string will be even. So a string can be a square string only if the length of the string is even. If it is not even, then it will definitely not be a square string. However, just because the length of a string is even, it does not imply that it is a square string. If you look at this example here, it has ABA, double AB. It is not the square string. Now in this example, if we split a string into two parts, two equal parts, we have ABC and ABC. So these two parts should be equal. Similarly over here, BAA and BA. Not even, then clearly the string will not be a square string, so we can output no. Now if the length of the string is even, we need to split the string into two parts. The first part will contain n by 2 letters and the second part will contain n by 2 letters. So for this, we will be using the substring function. In the substring function, we start from the 0th index and we have n by 2 letters. For the second part of the string, we will be starting from the n by 2 index. This can be clearly seen in this example. In this example here, we have ABC, ABC. So the second string should start from A. The index of A is 3 and the length of the string is 6. So we can clearly see that the second half will start from 3, which is 6 by 2, so n by 2. So in this code here, I have started the second substring from n by 2, and even this string will have n by 2 characters. Now, if the two strings are equal, then we should output yes, because the string will be a square string. And if these two are not same, then it is not a square string, and the output should be no. I hope this question is clear to everyone. And with this, we have another question here, which is there on Codeforces, so you can scan the code. Now for this question, I won't be coding the entire thing, but we'll just be going through how we can use the string functions. Sometimes words like localization or internationalization are so long that writing them many times in one text is quite tiresome. Let's consider a word too long if its length is strictly more than 10 characters. All too long words should be replaced with a special abbreviation. This abbreviation is made like this. We write down the first and the last letter of a word, and between them, we write the number of letters between the first and last letters. That number is in decimal system and does not contain any leading zeros. So localization will be spent as L end and the number of letters between L and internationalization will be spelled as I, the number of letters between I and N. So we can clearly see that in this question, first we need to check if the length of the string is greater than 10. Only if it is greater than 10, then we'll modify the string. And the new string will have the first character of the string, which is S of 0, the number of characters in between the first and the last letter, which is the length of the string minus 2, and the last character of the string, which is S of L minus 1, where L denotes the length of the string. With this, we come to the end of a session. I hope all of you understood what Shreya and I explained. In case there are any doubts, then I think we can take that up. Also, this is the feedback form, so you guys can scan it and give the feedback as to how the session was.
You can give attendance there as well. The form link is there.
Also, please don't forget to mark your attendance. The link has been shared in multiple places and the link is visible on the screen as well. Also, guys, please don't forget to leave your feedback. This will be very beneficial for the upcoming sessions. So please scan the QR and give us an honest feedback. Okay, guys, so post the session, the slides will be updated, and also we'll be giving you a problem set based on today's session, which you can solve within a week. I hope you guys understood, and I think if no one has any doubts, then we can end the meet. Okay, so we'll be ending the meet right